Hello everybody, welcome to another video on Thomas's calculus. Today we are going to look at chapter 9, first order differential equation. First differential equation we'll look at is y dy over dx plus x equals 0. So here the first thing we need to do is separate the variables. So we need to get all the x's to one side. So if we get x here and get the dx also to the other side, we will have the y's and the x's separated out. So we'll see, we'll write it as y dy over dx is equal to minus x. Now, next thing we'll do is bring the d multiply by dy dx. So we have y dy equals minus x dx. So this means we can integrate both sides. So if we integrate both sides, y and the antiderivative of y is y squared over 2 equals minus x squared over 2 plus c. We know there is a constant. If we want, we can multiply everything by 2. So we can get y squared equals minus x squared plus 2c, but this could be just written as a c. So we can write this as y squared plus x squared equals c, just a constant because 2c is a constant as well, and c can write c as a constant. So that is your solution. Let's look at another example. The next example is dy over dx equals x squared over y squared. So one thing we can do here is we can, first thing we have to do is separate the variables. We can bring the y squared onto this side and the dx onto this side. So let's do that. So it will be y squared dy equals x squared dx. It's very similar to the previous question. So that would be y cubed over 3 equals x cubed over 3 plus c. And we can multiply everything by y by 3. So we have y square cubed equals x cubed plus 3c is given as c. Now here, if we were given an extra parameter, say y1 is equal to 2, that means this is x. When x is equal to 1, y is equal to 2. If that is a boundary condition or an initial condition, then we can substitute it to y and x and get c. So here y is equal to 2, so it's 8 equals 1 plus c. So we see that c is equal to 7. So that if we have a condition of this nature, we can calculate the constant here. Do one more question. Next question is y dash equals xy given y0 is equal to 5. Now y dash we know is dy over dx is equal to xy. Now we are also given an initial condition or a boundary condition. All this says is that when x is equal to 0, y is equal to 5. When using this condition, we can get the constant. That's what we do with this. So for now, we'll try to solve the differential equation and get an equation of x, y and a constant. So here we have 1 over y, we bring y to this side, dy, because we have to have the variables separated, and we have x dx. And we can integrate now. So we know the integral of 1 over y is ln y. And we know the integral of x would be x squared over 2 plus c. So this is your solution, but we can simplify it a little further. So when we have an ln on one side and some value on the other side, we can always simplify it further by getting using e to the power. So we write on both sides, we get the power of e to the power ln y equals e to the power, this entire term, x squared over 2 plus c. Now, e to the power ln y is y. And then this can be written as a multiplication. That is, we can write this as e to the power x squared over 2 multiplied by e to the power c. So e to the power c can be is a constant, but I'll try to explain this further in a different color. So, for example, x to the power uh, 2 times x to the power 3 can be written as x to the power 2 plus 3. Similarly, x to the power 4 plus 7 can be written as x to the power 4 times x to the power 7. So that's the rule we use to separate these out. If it's multiplication, it can be written as, if it's addition, it can be written as a multiplicative function. So here we know e to the power c is a constant, so we can write it as y equals, sorry, maybe I should erase that and use a different color. The same color I used before because it's the same function. Y equals, we can use this as the entire function as c. So we can say c e to the power x squared over 2. Now, if we want to find c, we can substitute when x is equal to 0, y is equal to 5. So if we substitute that, we have 5 equals c e to the power 0. E to the power 0 is always 1. Any power to the 0 is 1. So c is equal to 5. So that gives us the entire solution of ln y equals x squared over 2 plus 5. That, sorry, 5, not c, it's 5. We'll look at one more example. The next question is very interesting. It says, show that every member of the family of functions. What does this mean, family of functions? What this means is, for every c, you get a different equation. And how do you get a c? For example, when y is equal to 1 and x is equal to 1, you get one solution with a different c in it. So let's substitute. If this is a member of the family of the solutions, this is a solution. For example, when y is equal to 1, it is 1 equals c over 1 plus 2. So c is equal to minus 1 here. C is equal to minus 1. So y equals minus 1 over x plus 2 is the solution for x. Y equals 1 and x equals 1. When x equals 1 and y equals 0, we see that it's 0 equals c plus 2. Here c is equal to minus 2. So then the solution would be 1 y equals minus 2 over x plus 2. So that's why, so you could have many solutions. As c changes, we'll have many solutions. So that's why it's called a family of functions. So we are asked to show that every member of this family of functions, we keep c as it is. We do not substitute anything for c. We keep it as c because keeping it as c makes it a family of functions really. So we keep it that way and we try to first we try to derive dy over dx from this equation. That's the first thing we do. Okay, so we know y is equal to c over x plus 2. So what would dy over dx be? That's differentiating y. So we differentiate this side also. We can keep c as it is, d over dx of this, and we know differentiation of a constant is 0, so we make that 0. So d we can as the constant, it's a constant, we can take it outside and we can write d over dx, and this could be written as x to the minus 1. So when you differentiate x to the minus 1, it is minus c x minus 2. You multiply by the power and subtract 1. So what we get here is, so we see that dy over dx is equal to minus c over x squared. So this is one equation that we have found. Now the next thing we want to do it, I'll change colors for that part. I'll make that purple. Next thing we want to do is, we want to take this part of the equation and substitute the y to this and see whether we can get the same thing as 1. So let me do that again. So we have 1 over x and we have 2, and y is, from here, y is c over x plus 2. So that's the equation. So what we can do here is, we can use x as the common denominator. So then we have 1 over x, and if we take x as the common denominator, this becomes 2x minus c minus 2x. So, and we know we can cross these off. I'll use a different color to cross these off. So then we have minus c over x squared, which is equal to 2. 1 is equal to 2. Therefore, we confirm that this is a solution for this first order equation, dy over dx, 1 over x times 1. So what you do here is, first we have this solution, the general solution. We differentiate and see what we get, and then we take their solution, their differential equation, and substitute the y and show that these two end up being the same. So the question is, show that the function y equals x plus 1 over 3ex is a solution to this first order function. First thing we'll do is, we'll look at the left hand side. So if we only look at the left hand side, so given y is equal to x plus 1 minus 1 over 3 e to the power x, we will derive dy over dx. So dy over dx is equal to the derivative d over dx of the entire thing here of y. That's what we're only looking at the left hand side. It is x plus 1 minus 1 over 3 e to the power x. So if you look at the derivative of this, we know the derivative of x is equal to 1, and this is 0, and we know the derivative of 1 over 3 e to the power x is minus 1 over 3 e to the power x, because derivative of e to the power x is e to the power x. So on the left hand side, we have found that this is equal to 1 minus 1 over 3 e to the power x. So let's look at the right hand side now. So the right hand side, y minus x. Let's look at what y minus x is. So I'm going to do the right hand side on the right hand. So y is, we substitute this y here. So y is x plus 1 minus 1 over 3 e to the power x minus x. That's your right hand side. This is the left hand side. Let me write it as left hand side. That's the left hand side and this is the right hand side. So if we look at this, we can clearly see that we can cross off these. We can cross off these because it's minus x and plus x. And then we see we get 1 minus 1 over 3 e to the power x, which is equal to this. So right hand side is equal to the left hand side. So we have shown the solution. And they also say uh, that at y0 it's equal to 2 over 3. That means when x is equal to 0, y is equal to 2 over 3. Is this correct? So let's substitute it to the right hand side or the left hand side. We substitute right hand side. So in the right hand side, when y, so y is in the right hand side, y is equal to 1 minus 1 over 3 e to the power 0. We know e to the power 0 is 1, so we have 1 minus 1 over 3 is equal to 2 over 3. So we have proved that when x is equal to 0, y is equal to 2 over 3. The next thing we'll look at is the slope field. So we are asked to match the equations, these differential equations, with the slope field. So let's take the first differential equation. First differential equation is dy over dx. The slope is equal to 1x plus y. If you look at this equation, we see when x is increasing, dy over dx increases. If when y is increasing, dy over dx increases. And also dy over dx is equal to 0 when x is equal to minus y. So the gradient is, when the gradient is 0, the slope field would look like this, a horizontal line. So when x is equal to minus y, the gradient is 0. So there should be a horizontal line. So if you look at this, when x is equal to 0, there is a horizontal line here. When y is equal to minus x, there is a horizontal line, horizontal slope. And here also, when x is equal to x is equal to minus y, there is a horizontal slope. So the gradient is 0 or the slope is 0 when x is equal to minus y or y is equal to minus x. So that means there should be, if this is your axis, there should be some 0 slope lines this way and there should be some 0 slope lines this way. So, and that means this is the correct answer for 1. Let's look at question number 2. 2 is dy over dx is equal to y plus 1. So it doesn't depend on x. So there should be a graph that does not depend on x. and dy over dx is equal to 0 when y plus 1, y is equal to minus 1. When y is equal to minus 1, sorry, I should write this better. So here we see that when y is equal to minus 1, dy over dx is 0. In other words, there should be horizontal lines when y is equal to 0 and it should not depend on the value of x. So if you look at that, when y is equal to minus 1, this is the answer, because when y is equal to minus 1, it's a horizontal line, and it it does not depend on x, it only depends on y. So second one is C. Let's look at the next question. dy over dx, that's the slope, equals minus x over y. Now, minus x over y. So, when x in the first quadrant, let's look at the first quadrant. This is the first quadrant. When x is positive and y is positive, gradient is negative. So first quadrant, negative. dy over dx is negative. Then third quadrant, dy over dx again is negative, because x is negative, y is negative. So we get positive there, and this should be a negative. So we see in the first quadrant, we see here the gradient is negative, and here the gradient is negative. And in the second and fourth quadrant, it's positive. So this would be this equation. So 3 would be A. Now let's look at 4. So we are left with D now. So 4 is dy over dx equals y squared minus x squared. So when y and x, for all y and all x, when y is equal to x, the dy over dx is equal to 0. So we are left with only d. I think I made a mistake here. So we are left with only d. So when y is equal to x, dy has to be equal to 0. So y is equal to x all this way, and y is equal to x here as well. So this should be A. So I made a mistake. So this should be B. So let me delete this. I'll explain this further. I think I made a mistake here. So this should be B. The fourth one should be B, because for what, even if x is negative or positive, when x is equal to y, whether it's negative or positive, the gradient is 0, the slope is 0. So it should give this pattern. Now we have to see why this y1 is equal to d. So let's look at this. So I'll have to erase this. This is incorrect. This part is incorrect, in fact. So here the gradient is equal to 0 when x is equal to minus y and y is equal to minus x. And that's only this side, because here y is equal to y is equal to minus x, and here x is equal to minus y. So that's the only time you get a zero gradient. So 1 should be D. So I made a mistake there. 1 should be D and 2 should be C and 3 should be A and 4 should be um, 4 should be B. So I'll go through 1 and 4 again because I think I made a mistake and I'm correcting it. So dy over dx, the slope is equal to x plus y. So when x is equal to minus y, dy over dx is equal to 0. When x is equal to minus x, and this is the only time when y is equal to positive, x is equal to negative, or x is equal to positive, y is equal to negative. So there should only be one horizontal gradients where gradient is not the gradient, the slope field is 0, should be only on in this direction. So that's why 1 is equal to this. 1 is equal to this. And in the fourth equation, whatever x value it takes, whether it's negative or positive, when x is equal to y is equal, when x is equal to y, dy over dx is 0. So we see that's why we get a, a pattern of this nature. So that's why the 4 should be equal to D. 4 should be equal to B. That's why 4 should be equal to B because whenever whether x is negative or positive, whenever x is equal to y, dy over dx is 0. I hope you understood that. And the slope fields are really important, and it's very important that you're able to identify the slope fields from the derivative. So you may see when the derivative is equal to 0. We know that when the dy over dx is equal to 0, we have a slope field of horizontal line. And when it's positive, it's a acute angle here. So that's when dy over dx is positive. When it's a larger angle, dy over dx is negative. So you have to increase and decrease and vary x and see what happens to dy over dx when x is equal to 0 or x is equal to y or x is equal to minus y to see how the slope fields vary.